Welcome all the students. Myself Dr. A.B. Nikumbh. I am going to teach you physical chemistry CH331 paper. In this paper we found there are 4 chapters according to Savitribai Phule Pune University syllabus. First one is chemical kinetics, second one is electrolytic conductance, third one is investigation of molecular structure, and fourth one is phase rule. All the chapters are equally important because when you get admit for suppose higher education and different competitive examinations, you will find the syllabus also includes all these points. That's why the basic things one should be clear. In this chapter we consider recapitulation, means whatever we have studied in the previous classes that we are going to consider, and today in this presentation we are considering only the recapitulation part, while the second, kinetics of third order reaction, methods to determine order of reaction, and Arrhenius equations, these points we consider in our next lecture. So we today consider the recapitulation, means introduction towards chemical kinetics. In this recapitulation we consider that the classification of reactions will be carried out in different ways, and one of the ways is on the basis of number of phases. So these phases, there are 3 different phases of states of matter. Solid state, we consider it as solid phase. Liquid state means liquid phase, and gaseous state means gaseous phase. So on this concept there are 2 types of reactions: homogeneous reaction and heterogeneous reaction. Homogeneous reaction means the reactions in which all the reactants as well as products are in one and the same phase. While in heterogeneous reactions, one of the reactant or the product, they are in different phases. For example, if you take the reaction of decomposition of calcium carbonate, that is the thermal decomposition, then we get the product as calcium oxide and CO2. In this reaction we found calcium carbonate is in solid phase, calcium oxide is in solid phase, and CO2 is in gaseous phase. So this is the example from heterogeneous reactions. Let us take another example, that the formation of hydrogen iodide from hydrogen and iodine. Here hydrogen is gaseous phase reactant, iodine is also in the vapor form, means the gaseous phase, and we get the product hydrogen iodide is also in the gaseous phase. So this is the good example of a homogeneous reaction. Now if we consider hydrolysis of an ester, this is also one of the good example of homogeneous reactions in which all the reactants and products are in the liquid phase. Now in this recapitulation we are considering here the very important term, and that is rate. This rate means the velocity or speed of the chemical reaction And definitely, whenever we consider velocity or speed, it is related with time. For the chemical reactions, rate will be represented by dx by dt as a simple notation. So in this dx by dt means dx infinitesimally small change in concentration and dt infinitesimally small change in time. It means change in concentration per unit time is called as rate. In other words, if we consider it with respect to reactants, then definitely whenever any chemical reaction proceeds, concentration of reactants go on decreasing, and on the contrary, the concentration of products go on increasing. And that's why rate, whenever we consider with respect to reactants, it has negative sign. It has a significance that the concentration of reactants decreases. Rate is never negative. It is always a positive quantity. Negative sign is indicating here that the concentration of reactants decreases as the reaction proceeds. While in terms of products, if we consider, the concentration of the products increases, and that's why rate will be represented by positive notation dx by dt itself. X is the concentration and t is the time in the rate notation, and that's why concentration divided by time is the unit of rate. If we measure the concentration in normal terms, if we measure the concentration in molar terms, in mole fraction, in terms of volume, in terms of weight, different ways are there in which the concentrations are measured. While the measurement of time also having the different units, may be measured in seconds, maybe in minutes, hours, days, in weeks, months, years, etc. And therefore, the unit of rate is concentration into time raised to -1. If we measure the concentration in moles per liter and suppose time in minutes, unit of rate is moles per liter per minute. In this way, this term can be understood. The rate of any chemical reaction can be represented by rate equation according to rate law, and this will in turns related with the law of mass of equilibrium. So here we find the rate is supposed directly proportional to the concentrations of reactants. Now let us consider the general reaction A plus B gives C plus D, where A and B are the reactants and C and D are the products. So according to the rate law equation, for this reaction, dx by dt is proportional to concentration of A into concentration of B. So we found this according to the equation. Now whenever we consider this is to be simplified, then one should to remove this proportionality sign and one can introduce there the proportionality constant, and you will find this is called as rate constant and always represented by small letter k. So dx by dt equal to k into concentration of A into concentration of B. So here we find K is very important in the rate law equation, and one can define this K rate constant can also be called as specific reaction rate constant as a rate of reaction. Rate constant is nothing but rate of reaction when concentration of all the reacting species is unity. Means when in this equation concentration of A equal to 1, concentration of B equal to 1, then the equation simplifies to dx by dt equal to k. So rate constant is equal to rate, but it is possible when we assume the concentration of reactants be unity. We consider here about the term chemical kinetics. This kinetics is the science where we study the rate of reactions, factors affecting rate of reactions, as well as the mechanism which is performed in the chemical reaction. So this kinetics, when it is related towards chemical reactions, then it is termed as chemical kinetics. So chemical kinetics is the study of rate of chemical reactions, factors affecting the rate of reaction, as well as the mechanism that is included in the chemical reaction. Okay, now we consider in brief about the factors affecting reaction rate. First one is temperature, concentration or pressure, nature of reacting substance, catalyst, solvent, viscosity of solvent, and many others. The first very common and important factor is temperature. Generally, we found that whenever temperature increases, reaction rate also increases. This is the very common factor, and in general it is observed that when the temperature increases by 10 degrees Celsius, reaction rate approximately doubles. Reaction rate approximately doubles, and this can be explained according to Van 't Hoff rule also. According to Van 't Hoff rule also, that is the rate constant at higher temperature divided by rate constant at the normal temperature or lower temperature. This ratio gives us the rate coefficient with respect to temperature, and that's why this temperature becomes the one of the important factor. Now we consider second factor, concentration and or pressure. When the reaction is carried out in solution phase, then the concentration of solutions is important, and when the reacting species are in the gaseous phase, their pressure is important. And also it is generally found that when the concentration of reactants or pressure of reactants increases, the reaction rate also increases. Now we consider third factor, nature of reacting substance. If you find the reacting substance is suppose in the solid state, lumps, then it reacts slowly. If it is in the powdered form, it reacts somewhat fast, and if it is in the solution form, then well, it is reacting with a faster rate. It means the nature of reacting substance is also important for the study of rates. The another factor is the catalyst, which is also important, and we know this catalyst is the species which alters the rate of reaction. There are two types of catalyst, positive catalyst and negative catalyst. Positive catalyst is used to speed up or enhance the rate of reaction, while negative catalyst is used to control or to retard or to reduce the rate of reactions. This catalyst is also one of the part from the chemical reactions if are present and they are counted for the classification 2. In which state it is present, that is important. Another factor is solvent. We know the solvents are generally classified into two types: polar solvents and non-polar solvents. If the reactants are polar and solvent is also polar, the rate is faster. And that's why the nature of solvent is important here. Another one is viscosity of solvent. If the solvent is more viscous, means the reaction speed is less. And if the solvent is less viscous, the reaction speed is somewhat greater. So all these conditions or factors are important here. The another part that we are going to consider is the classification of reactions on the second point, and that is on order and molecularity, on the basis of order and molecularity. You are well familiar with this particular term, order, and also the molecularity. According to order, first order reaction, second order reaction, third order reaction. According to molecularity, unimolecular reaction, bimolecular reaction, termolecular reaction, etc. Now we consider in brief about what is order and molecularity. Okay, order is an experimental quantity. It changes with the experimental factors or conditions. And that's why it is important while studying the chemical kinetics. Now, whenever the order of chemical reactions is evaluated or determined, it can be determined from the summation of the exponents of the concentration terms from the rate law equation that is obtained from the stoichiometric form of the chemical equation. So this order may be 0, it may be fractional, it may be whole number integer. While if we consider about the molecularity, it is never 0, it is never fractional, it is always positive whole number integer. Order is theoretical quantity which can be obtained by summing up all the reactants, maybe molecules, maybe atoms, maybe ions, from the stoichiometrically balanced chemical equation. So one can differentiate both these terms, order and molecularity, with respect to definition, with respect to example. If you consider the example of, as I stated earlier, thermal decomposition of calcium carbonate, then it is found that this reaction is of first order. It is heterogeneous reaction. And the same reaction you may call this as a molecularity is also 1. But if we consider in either way the other examples, then you may find the order and molecularity are different. If the order and molecularity of the reaction or equation, chemical reaction is same, then they are the true reactions. While if the order and molecularity for the given chemical reaction are different, then they are known as pseudo-molecular reactions. So in this way, the differentiation between these terms one can consider. So let us sum up that how we account about the recapitulation of chemical kinetics, in which we have seen about the different terms like rate, chemical kinetics, rate constant, unit of rate constant, factors affecting the reaction rate, order, and molecularity. Now, with the same concepts, in our next lecture, we continue for the actual kinetics for third order reactions. So let us stop here. Thank you.